You have spent about 1 month so far watching events from the history of the universe, so perhaps this is the right time to pause and review what we have seen so far. You saw that the universe was created about 13.8 billion years ago, and that its origin is the biggest mystery of this whole story because we are unable to reconcile the laws of quantum mechanics with the laws of gravity, and this leaves us incapable of making any testable predictions about the origin of the universe. You also saw that the famous Big Bang was not in fact the origin of the universe, but the end of an earlier epoch called inflation, in which energy was created out of empty space. However, once inflation ended, and so released the energy in the Big Bang, it was thereafter impossible to create energy. From this tiny fraction of a second after the creation, we have followed the story of how particles emerged, especially protons, neutrons, and electrons, and how they joined together into atoms. Initially just hydrogen and helium. We also noticed the much more common but totally mysterious dark matter, about whose nature we know nothing. The gravity of this dark matter concentrated the atoms into lumps which eventually lit up as stars. There, hydrogen nuclei were fused into helium under the pressure of gravity, converting matter energy into radiation, which we see as starlight. Towards the end of a star's life, we saw how they swelled up into red giants, where larger nuclei were created, including carbon, nitrogen, and oxygen. And the heaviest nuclei they could form were iron. We saw that during the final stage of a star's life, it exploded in a supernova, and here very heavy nuclei such as uranium were created and thrown out of the star, along with all the other particles which the star had made. All that was left of the star now was a heavy object which in some cases formed a black hole. We followed the new particles as they were thrown out of the star, collecting electrons as they went to form new sorts of atoms. We saw how some of these were able to become ions by gaining or losing electrons and so sticking together with strong ionic bonds to make stardust. We also saw that other atoms did not form ions, but instead they were adsorbed onto the surface of the dust, and here they stuck together by sharing electrons to make weaker covalent bonds. And we learned that the atoms which can make 1, 2, 3, or 4 covalent bonds were which atoms? Can you remember? 1 was hydrogen, 2 was oxygen, 3 covalent bonds is nitrogen, and 4 is carbon. And I said that the way to remember this is to remember the word honk. 1, 2, 3, 4, honk. A group of atoms stuck together with covalent bonds is called a molecule. This is a molecule of water. Water molecules are able to stick together with even weaker bonds called hydrogen bonds. And these bonds joined water molecules into layers of ice around the stardust. We saw that gravity concentrated the gas around these early stars to form galaxies, which often form in clusters, and clusters are organized into whorls and filaments, separated by huge empty spaces. Because they were rotating, galaxies often took on the shape of a flat disk. The one we live in is called the Milky Way. It might look like this from the outside. It has spiral arms made of density waves. As gas and dust pass through these arms, they are given a jolt and begin to contract once more. This forms a group of stars in an open star cluster. The Sun was formed in this way about 4.6 billion years ago. The gas and dust surrounding the young Sun was also rotating, so it too formed a small disk. Here the icy mantles stuck the stardust grains together to form larger and larger clumps. These clumps are called planetesimals. And finally, gravity gathered these clumps into planets. And finally, we looked at the young Earth and saw some of its inner structure. The inner core, the outer core, the mantle, the volcanoes which arose to form the atmosphere. For the rest of the story, we will focus down on our home planet, but we must not forget that it is just one of many hundreds of known planets, and there are almost certainly far more planets yet to be discovered. They are difficult to observe because planets are small and dark, and so they are hidden by the light of the stars they orbit around. But we know that there are hundreds of billions of stars in each galaxy, and we know that there are hundreds of billions of galaxies in the universe, so it seems very likely that there are many billions of planets in the universe. One of the key questions we will be thinking about in future episodes is there life only on the Earth, or could it exist elsewhere, perhaps on many of those other distant planets?